So yesterday we talked about how a square gives us the maximum area for the minimum perimeter, or we could say that it gives us the maximum, minimum, okay, two things. Sorry, maximum area for the minimum perimeter. It also has a minimum perimeter for the maximum area. Same thing, but just said two different ways. Now, let's recall. I'm going to do a question similar to what we did yesterday. We have a hobby farmer making a fenced yard for her horses. She has 90 meters of flexible fencing. Now, because it's flexible, that means it could be folded at anywhere. If she's making a four-sided rectangular yard, what's the maximum area that she can enclose? Now, one thing we do know, we remember the principle that a square will give you the maximum area for the minimum perimeter. And so we have a perimeter of 90 meters. Let's divide it by 4 so that we can find the sides. 90 divided by 4. So the dimension is going to be 22.5 meters times 22.5. And our area will be 22.5 times 22.5. 506.25 meters squared. Now let's say that we already have one existing fence. So it's going to border on that. What's the maximum area that she can enclose now? Now we're only looking for a 3-sided rectangle. And so our perimeter would be equal to 2W plus 1 length. The area is still length times width, but let's sort out the information we have. Now I know that the fixed amount is 90 meters. So we have 90 is equal to 2W plus L. I can rearrange it so that I have L is equal to 90 minus 2W. Now that we've rearranged our equation, we can substitute this into our area because I want to maximize the area. So since area is length times width, I'm going to write area is equal to 90 minus 2W times W. So I can just use this equation, and I'm going to put this into a graphing calculator now. So 90, was it 90W or 90 minus 2x times x. Okay, let's just define our variables. Y is the area and x is the width. So I got these variables just based on here. This is my y and these are my x's. Now we have to see where we're going to get a maximum. And we have to zoom out a bit. Okay, so we zoomed out. Point of intersection. 22.5 and 1012.5. Okay, so we know that this is the width and this is our area. So let's go back to answer our question. So we can interpret this as the max area is 1012.5 meters squared. And the dimensions, width is 22.5. Length, we had defined it as this. So now length is equal to 90 minus 2 times 22.5. And we get 45. So 22.5 meters by 45. Okay, so this is what we talked about yesterday, and using a graph to help us answer questions, to find the maximum or the minimum. Now, let's extend it. Let's say that this farmer wants to have 90 meters of flexible fencing, but it's going to create a circular yard instead of a rectangular one. So because we're looking at this shape, we're going to use our equations for a circle now. So let's recall, perimeter of a circle is equal to the circumference. Circumference is 2 pi r. And our other equation for area, pi r squared. Okay, so let's write down what we do know. We know that 90 meters has to be the perimeter. How do I know? I look at the units, there's no exponent 2. That indicates that I'm in a one-dimensional distance, so perimeter. So I have 90 is equal to 2 pi r. Well, we know that pi is 3.14. So I'm just going to rearrange this. So I have r is equal to 90 over 2 pi. It's going to give me a decimal answer, so I'm not going to type it in right now because I don't want to round my answer until the very end. So once I'm here, let's take this and substitute it into my area equation. So area is pi r squared. Area is equal to pi times 90 divided by 2 pi, all to the power of 2. Let's type this all into the calculator at once. So pi times 90 over 2 pi, exponent 2. Right, so I have my final area here of 644.6. Now, what's interesting is here with the circle, you have no wiggle room. Unlike a square, a circle is always a circle. So once I've substituted my numbers in, I only have one variable. The variable is actually solved already. So we are rearranging, we find the radius, and then you plug it in to get your area. Now, slide 5 and slide 6, I would like you to try some of these questions. So we're talking about Lindsay has 20 pipe cleaners, each measuring 8 inches long. So she wants to create a rectangular frame with the largest possible area. Then she wants to create a round frame with the largest area. So find those Secondly, we have another question. Salman wants to create 1,000 square feet. Now, this is area. What's the minimum amount needed to go around this garden if the garden's rectangular or if the garden is circular? So I'm going to give you a little bit of time to answer these questions. I will be taking a look at what you're doing and write some feedback as you're going. Okay, so this question, Lindsay has 20 pipe cleaners. Each of them measure 8 inches long. If she creates a rectangular frame, what's the largest possible area? Now we've got two choices now. We can either use 20 and calculate the dimension based on the units of pipe cleaners, or we can convert it into inches so that I know my total distance is using inches and it will be 160 inches long. Your choice. If actually, I'm going to do it by pipe cleaners. So just to note, using pipe cleaners segments as the unit. So we have perimeter of 20, and I know that would mean my side is equal to 5. Okay, so our dimension is 5 segments by 5 segments. Or we could say this is 40 inches by 40 inches because we know that each segment is 8 inches long. So our area now is 25 segments squared, or square segments. Or we could say 1,600 square inches. Okay, now if we're creating a circular frame, we can go back to figure it out. Once again, I'm going to use pipe cleaners as my segment. So my circumference in this case is 20 pipe cleaners long. So that means circumference is 2 pi times r. But if I substitute my numbers in, I have 20 is equal to 2 pi r. And I can rearrange this to express it in terms of r. Now, there are no more variables in here. I would get 20 divided by 2 pi, which ends up being 3.183098862, and it keeps going. And even though I do have a number, I would rather keep it as a fraction because the answer is going to be more accurate at the end. Now let's substitute this into our area to get our maximum area. Area is equal to pi r squared. So I would have area is equal to pi times 20 divided by 2 pi, all to the power of 2. So now let's throw it into the calculator. So we have pi times 20 divided by 2 pi, all to the power of 2. And area 31.83 segments, square segments. Okay, that's one way to look at it. Another way we could look at it is to convert this into inches. Okay, so if we convert it to inches, we know that 1 square segment is equal to 64 square inches. How I got this relationship is because I know that 1 pipe cleaner by 1 pipe cleaner is going to be 8 by 8. So we have that. Now, I'm going to convert from 31 square inches. We're going to use our conversion factor. So 31.83 square segments over over an unknown number of square inches. This is equal to 1 square segment over 64 square inches. So let's cross multiply. 31.83 times 64 equals x. Okay, x is equal to 31.83, 2,037.12 square inches. And so our circle one is producing a larger area than our square one. But we've used the same materials and we have exactly the same perimeter, just a different shape and a different area. Okay, let's do another question. This question, Salman wants to create a 1,000 square foot garden. What's the minimum amount that's needed to go around it? So we have a fixed area. This area is what he has to have. And we need to know the perimeter to go around it if the garden is rectangular. Now we know that minimum perimeter would mean that we need a square. So area is 1,000 square feet. Let's divide it by 4 and we have, or sorry, that doesn't work. Okay, area is equal to length times width. And in this case, because it's a square, I'm just going to take the square root to get one of the sides. So side is equal to the square root of 1,000. So we have 31.6 feet. Right, so our perimeter is going to be 4 of those. $126.4 feet. All right, let's do this for our circular garden. Area is 1,000 square feet, but the area is also pi r squared. Let's rearrange this so that I get my r. R squared is equal to 1,000 divided by pi. And then we have the square root of 1,000 divided by pi. So this is my radius. It will give me a number already. However, I'm not going to do it because I would have to round it. So I'm going to keep it the way it is and then substitute it into my perimeter equation. So perimeter of a circle is circumference. Circumference is 2 pi r. Okay, so 2 times pi times the square root of 1,000 divided by pi. Let's put that into our calculator. And we have a circumference of 112.1 feet. Now, once again, the interesting thing is the circle actually maximizes it better. So the circle will take less perimeter, but give you the same area than a square. Okay, let's take a look at this question now. This question is something that we did yesterday. So let's say Mohammed has a summer job working at a campground. He's roping off a rectangular swimming area on the beach, and he has a rope with 50 boys. So these are the boys. Each of them are evenly spaced at 6 feet intervals, and there's 4 support stakes to anchor the boy ropes down. Ignore this part, it is completely irrelevant to the question. Now, what we do know is we have 50 of these at 6 feet intervals. So once again, we can express things in terms of boys, or we can use the unit of feet. Probably using the unit of boys is easier because you've got less of them. Okay, so let's start solving our problem. Which area is fixed? Well, I haven't talked about area, but it's told me that I've got my 1 dimension of rope. The rope is 50 boys long, or 50 times 6 feet. So I know that that gives us perimeter. Great, let's write down the equation. And actually, I'm going to draw a picture too. Okay, so we've got some water here. And I have my barriers. So I have 2 widths, I have 1 length, and then each of these barriers, there's like little boys that are 6 feet apart. All right, let's write down what we do know. I know that the perimeter is equal to 50 boys. Another thing I do know is the perimeter in this case is 2W plus 1 length. Let's combine those together. So we have 50 is equal to 2W plus L. I'm going to rearrange this. So I have L is equal to 50 minus 2W. I've just taken the equation and I've rearranged it so that I've got a variable here. Okay, I need to combine this equation with the area equation so I can find the maximum. Area is equal to length times width. But once again, because length times width is kind of unknown, I have to use this relationship. And this is why I rearranged it so that I can express it as just one variable. Okay, our area is now 50 minus 2W times W. Okay, I need to find the maximum area. So I'm probably going to have a graph that's going to give us the maximum. Let's go over to the next page to use our graph. So y is equal to 50 minus 2W or 2x times x. Right, so let me define that. Y is area and x is the width. Right, I've put it in here. It is not fitting in my screen, so I'm going to just change my field of view. Maybe that's too much. Okay. And I have a point of intersection at 12.5 and 31.2.5. Oops. Okay, so when I write POI, that means point of it's not point of intersection. This is the maximum, sorry. Maximum 12.5 and 31.5. 31.2.30, 312.5. Oh my goodness. My tongue is not working today. All right, so we have a maximum of 12.5, 312.5. So what that tells us is our width. Remember, we're working in the unit of boys, 12.5. Okay, so this 12.5 boys long. Okay, let's substitute it back into the equation. If I want the length, I have 50 minus 2w. And my length here is 25. Okay, so the area, I can use this unit. So I have area is 12.5 times 25. $12.5 times 25. Okay, the units that we were in, 312.5, but our unit is using our ring boys. Not highly useful when we are talking about it with other people because this unit is somewhat meaningless. So we should convert this back into feet. Okay, so let's convert this. 12.5 boys, we know that each one is 6 meters. So that means we're going to have 12.5 times 6, and this is 75 feet. Right, 25 times 6 over here, this is going to be equivalent to 150 feet. Okay, so let's use area now in terms of feet. Area is 150 times 75 feet. $100 times 75, 11,250 square feet. Okay, so this unit is now a bit more meaningful than this in ring boys. You can convert it either way. So find what 1 by 1 is, or and then use the conversion that we did in the last page, or we can convert our singular units to feet and then find the square feet. Okay, now what if the barriers were solid? So this, you'll notice here, these aren't flexible because it's not rope. It's like a solid plastic. So we can't fold it anywhere we want. kind of like these ones here. We kind of folded it and we had half. Instead, if it's solid, we have to use 6-foot segments. Oops, this is 6-foot segments to fence it off. Okay, so I still have this, but my dimensions must be a whole number. Okay, so since we have to have a whole number, let's go back to see on our graph, what are the possibilities for a whole number? Okay, so on my graph, if I take my cursor and I kind of walk along, you can see how things are changing. So at 10, I have 300. At 12, it's 312. At 13, I have 312 as well. So these two are probably my closest ones. Okay, I'm going to zoom in here just to see where these things intersect. So the two places where it intersects and it's a whole number would be at 13 and 12. So those are the clearest ones. Right, so we can't use 12, or sorry, 12.5. Our options are to use 12 or 13 buoys on the width. Oh. Okay, so let's say we did use 12. We have 12, 12, and then we have length is equal to 12 times 2, which gives us 24. The other option, if we did 13, then we would have 26. Does that work? No, that doesn't work. Let's check our equation again. Our equation 50 minus 2W. Okay, so that one 12 by 26, or we would have 13 by 24. Okay, so let's write the dimensions, but in feet now. So 12 times 6, that gives us 72 feet. And 26 times 6, 156. Okay, or we can have 13 times 6. Now these would produce a slightly smaller area, but sometimes these are the constraints if we have a solid barrier. Okay, I'd like you to try this on your own now. Slide number 10. I'm going to check how you're doing. And then after slide 10, there are 4 practice questions. And after the practice questions, when you're confident, you can go on to quiz number 11. Now I'm going to open up part 1 as well. So if you were stuck on stuff from yesterday, I am open to helping you with both of that content. Okay, so that's it for me talking today. The rest of the class will be a work period, and hopefully we'll be communicating back and forth so that I can help you out with your work.